Hi, my name is Daniel Manuel, and this is Lab 1 Charge Tape. Introduction. In this lab, we will prepare charged pieces of tape and observe their interactions to determine approximately how much excess charge is in one piece of charged tape. The process in doing so will be explained, but looking into the results, we found the excess electrons to be 5.22 times 10 to the 10 electrons. Some assumptions were made, including ignoring air resistance on a moving object, treating the tape as a point charge, and assume that each U-tape has an evenly distributed charge throughout. Fundamental equations and principles include gravitational force, Coulomb's law, and static equilibrium. The process. So during the lab, the U-tape was found to have a positive charge. This was determined by holding two U-tapes together and observing them repel. Thus, they are the same charge. To determine if that charge is positive or negative, we need an object of known charge, such as a pen that was rubbed through our hair to create a negative charge. The U-tape was attracted to the pen, therefore we know that the U-tape had a positive charge. This diagram shows the process of holding the U-tape to a second piece of tape to achieve equilibrium, so that we know the gravitational and electric forces cancel out. This will help us in finding the charge of the tape and the amount of excess electrons that we have. So here are results. We started off with a tape with a length of 0.178 meters, a width of 0.023 meters, and a separation distance of 0.019 meters. This is the distance between tape A and tape B in the diagram in the previous slide. The force on tape due to gravity is 1.74 times 10 to the negative 3 newtons. The surface area of the tape is 4.09 times 10 to the negative 3 meters squared. And then the number of atoms is achieved by dividing surface area by the area of one atom, which is 1 times 10 to the negative 20 meters squared. And we get 4.09 times 10 to the 17 atoms. Next, we found a charge of U-tape, and we did that by rearranging the electric force equation and substituting in gravity. And doing this, we got 8.35 times 10 to the negative 9 coulombs. Our excess electrons are found by calculating the charge of the U-tape and dividing that by the charge of one electron, which is 1.60 times 10 to the negative 19 coulombs. And doing this, we got 5.22 times 10 to the 10 electrons. Ratio of excess electrons to atoms is 1 electron to 7.8 times 10 to the 6 atoms. Here is our glow script model that we created for the computational part of this lab. The two dots on there are the point charges of the tape. Tape A is red, tape B is blue. And lines 2 through 6, we have all the constants, which include K, charge of electron, gravity, mass, and then the separation distance denoted as R. And then on 11 and 12, we find the force of gravity and the force of the electric force, which is the negative of gravity. After that, we find the charge, and then we plot those on to arrows. So the cyan arrow is the force of gravity, while the magenta arrow is the electric force, and those are denoted in the glow script model. What if electrons had positive charge and protons had negative charge? What would change about the observations you made with your tapes and other charged objects? The experiment would still have run the same, since the charges of the tapes would still be opposite than the tape in the bridge and would still get repelled. Why is it important to handle the charged tapes as little as possible? What happens when the charged tape comes into contact with your hands or other objects? It is important to handle it very little and be careful, because the charge on the tape would become neutralized as the electrons from your hand flow to the tape to cancel out the positive charge. Experimental error. Some errors I experienced that may alter the outcome of the lab were encountered when I first handled the tape too recklessly, allowing for the charge of the tape to become neutral. I fixed this by being more cautious and timelier when handling tape. Thank you.